In this video, we're going to talk about how to write a system of linear equations that represents a given situation. So before we get into writing systems, let's review how to write a linear equation to model a situation. So a photo printing shop charges $15 per order plus 25 cents per print. Write a linear equation that models the total T as a function of the number of prints P. So let's first look at the important information in this problem. So we have $15 per order and then 25 cents per print. So we're talking about the total T and the number of prints, which is P. So let's first identify the variables. So we have T, which is the total, and we have P, which is the number of prints. So if we write an equation for this situation, we know that the total equals $15 plus 25 cents per print. So this will be the linear equation that models this situation. So what we're going to be talking about in this unit is a system of linear equations. So sometimes we'll have situations where we need more than one equation to solve a problem. So a system of linear equations will have two or more linear equations. This year in Algebra 1, we're just going to be working with systems that have two equations and two variables. So the systems that we're using will be like this. We'll have two equations, and the reason we have two equations is because we have two variables. The number of variables must equal the number of equations in order for you to be able to solve a system. So we're going to use these strategies that we talked about with solving word problems. In today's lesson, we're just going to be using these first two steps because all we're going to be doing is setting up the problem. We're not going to be actually solving the problem to find values for the variables. That's something that we're going to be doing in a later lesson. So in today's lesson, all we're going to be doing is understanding the problem. So we're going to be defining the variables, finding the important information, and then we're going to make a plan to solve the problem. So that means we're going to be setting up the equations. So that's all we're going to be doing in today's lesson. So remember, we have this chart of the words that represent math symbols. All of these symbols can be represented by these different words and phrases. So you should be on the lookout for these words and phrases when you're reading these word problems. So let's look at this first example. It says you and a friend go to El Super Taco after school. You order 3 soft tacos and 2 burritos and pay $11. Your friend pays $8 for 4 soft tacos and 1 burrito. Write a system of equations that can be used to determine the price of a taco, T, and the price of a burrito, B. So let's first highlight the important information here. So you order 3 soft tacos and 2 burritos for $11, and then you have $8 for 4 soft tacos and 1 burrito. So we have a system of equations, and we're going to talk about the price of a taco, T, and the price of a burrito, B. So when we talk about this problem, let's first identify the variables. So we have T, which is the price of a taco, and then B, which is the price of a burrito. And we also have two situations that are described here, right? We first have you. So you buy 3 soft tacos, so that would be 3T. And remember, and usually means a plus sign. So we have 3T plus 2 burritos, which is 2B. And that equals a total of $11. So we have that equals $11. Then we have your friend who orders 4 tacos. So that would be 4T. Once again, we have our and. So that is plus 1 burrito, which is 1B. Or you can write just B. And that equals a total of $8. So we have that equals 8. So now we have two equations, right, that represent two unknown quantities, B and T, and that is now our system of equations. Okay, so we're not going to actually be solving the system. We're just going to leave it as it is because we have just set up our system. That is all it wants us to do in this lesson. So let's look at this next problem. A customer at a store paid $64 for 3 large candles and 4 small candles. At the same store, a second customer paid $4 more than the first customer for 1 large candle and 8 small candles. The price of each large candle is X, and the price of each small candle is Y. Write a system of equations that can be used to find the price of each large candle and each small candle. So let's see what's going on here. So we have $65 for 3 large and 4 small. Then somebody else is paying $4 more than the first customer for 1 large and 8 small. And then each large candle is X, each small is Y. And we once again need a system of equations. So let's first define our variables. So we have X, which is the price of large candles, and then Y is the price of small candles. So let's set up our equations. So we have customer 1 who is paying, let's see, $64 for 3 large. So 3 large is going to be 3X plus 4 small, which is 4Y, and that is the total of $64. Okay. Then we have customer 2. So customer 2 paid $4 more for 1 large and 8 small. So 1 large is going to be 1X, or just X, plus 8 small, which is 8Y. And then they paid $4 more, okay? So it's kind of a little tricky the way they wrote this. So what they're saying is that they paid $64 plus 4, right? So that's going to be $68. They don't tell you exactly how much that person spent. Instead, they tell you in terms of what the first customer spent. So these two equations right here, okay, this 3x plus 4y equals 64, and the 1x plus 8y equals 68 will now be the system of equations that we can use. So in this problem, it says there are a total of 10 apples and bananas in a bowl. The number of bananas is 3 more than twice the number of apples. Write a system that can be used to find the number of apples A and the number of bananas B. Okay, so we have a total of 10 apples and bananas. The number of bananas is 3 more than twice the number of apples. And then we want to write a system for the number of apples A and the number of bananas B. Okay, so we have our two variables, A, which is the number of apples, B, which is the number of bananas. And let's think about what this problem is telling us. Okay, so we have this important word here, which is total, right? Total means we add everything together, or in other words, it's the sum, right? So the total of everything all put together is 10. So we say that apples plus bananas, so A plus B, equals 10. Then it says, okay, so this is an interesting sentence. It says the number of bananas, okay, is 3 more than twice the number of apples. Okay, the reason I recopied this sentence is because it has a lot of words that directly turn into math symbols, okay? So like the number of bananas, we know that that can be represented by B, right? We've already defined that as B. So the number of bananas is B. Is one of those words from our chart. Is means equals. So we would say B equals, and then we have 3, right? So 3 is just a number, so we're going to write 3. And then we have more than, okay? 3 more than is one of those phrases that's in our chart. It means plus. So we have 3 plus twice. Twice is another math word, right? Twice means 2 times. So 2 times the number of apples, and once again, the number of apples is A. So we can say 2A. So I really like this sentence because this is a sentence where every single word can actually turn into a math symbol. So we get the equation B equals 3 plus 2A just directly from this sentence. So now we have our two equations, right? We have A plus B equals 10, and we have B equals 3 plus 2A. Okay, so now we have two equations that represent the two variables. So we have written our system of equations. So in summary, remember when writing systems of equations, you're going to have two equations, right? We have two equations because we have two unknown variables. You're going to identify the knowns and unknowns in each problem and then write each equation individually.